So then we have collision detection. So you can't really have a game without collisions. Collisions are the bullets hitting, a character. It's a car crossing the finish line. It's, Mario jumping on a Goomba's head. It's everything. All the interactions in a game are essentially collisions. So this can be a very expensive process. Actually, it is a very expensive process. And one of our goals is always to figure out how we can either do it as quickly as possible or make it seem as lifelike as possible in the quickest amount of time, so we can keep doing more and more and more of it. So you see this picture from EA's Fight Night of this guy getting punched in the face and the reaction that he's getting from it. The technique is actually very similar to some of the things we've seen in very old games where they use a technique called bounding boxes or bounding spheres. And they may not be using this, but this is one of the classic computer science tricks for doing collision detections in games, which is essentially, if you have a large object, find the smallest, box or sphere that you can put around it that closely mimics its shape, and then find if anything intersects with it. And the reason you use either a square or a sphere is that the calculation is very simple. To figure out if something is hitting a sphere, you just find the middle point, and then if anything is within that radius of that middle point, then it's colliding. Therefore, you have a collision, up the game accordingly. So to do this, you need to have a very strong background in trigonometry, geometry, linear algebra as well. So again, math becomes a pivotal point in the creation of games. And the last one I wanted to bring up is that modeling the real world is essentially a game of physics. And we're at an exciting point in time in games where a lot of games are so just graphically gorgeous that they can no longer just simply say that we look better than the next game because there are so many other great games. So different features that people are putting into the games for gameplay mechanics become more important. So you can see, say like a game like Burnout where like the car accidents are sort of the showcase, which is an example of physics. Or a game that I worked on, Project Gotham Racing 4, one of the showcase features that it had was it allowed drivers to drive in various weather conditions, in the dry, in the rain, in the snow, and adjusted the way that the car drove accordingly. Now this is all just a series of physics calculations. You're adjusting it, basing it on the coefficient of friction between the road and the tires. So an understanding of physics is necessary as well. So hopefully, with this little brief tour of the world of video games, I've at least enticed you to have some interest in it. So hopefully you're wondering to yourself, how could I get involved? What should I be doing now? So I steal a quote from Michael Jordan. I believe in playing early and learning late. So I think with anything that you do that you want to work really hard on and that you want to have great success, you've got to be passionate about it and you have to love it. So I won't start by telling you that you need to go out and get a whole bunch of computer science books and math textbooks and just start studying that and magically things will fall in place. The most important thing I would say is, immediately, is to just play video games. Have a great time doing that. If it's not video games, go to your favorite websites and figure out how they work and get really excited about playing around with them and understanding how those work. Because eventually, I'd say that programming is a very difficult job. It's very hard, it's taxing, you can get into a lot of problems that will cause you to just look and stare at the screen for a long amount of time. So the passion you have for what you're doing, I think, is going to be the thing that carries you from just working on it to get it done to really wanting to see it turn into something great. But I guess to be a little bit more specific, obviously we've talked about the importance of math, the importance of physics. So take as many and as difficult a physics courses as possible. Learn to program, get involved with computer science, as early as possible once you're done playing games. But we've talked about playing games. But start creating stuff. Once you understand what type of games you like, how they work, look for ways to ask the question, well, how could I do something better? Traditionally first-person shooters, as mentioned, like Halo, have been a great place for people to get started in figuring out how games work, because so many of them come with level designers where you can actually play with the geometry and start creating your own versions of the game. A new game for the PlayStation that came out last year, Little Big Planet, will probably be another big one because it allows you to make your own levels and share them and see how other people are doing it. For people who've started programming already, they can get involved with creating their own games with Flash or Microsoft offers a tool set, XNA Game Studio, which will allow you to actually write code to create games as well. And most importantly, I'd say just get involved. Don't just sit around by yourself and play games. Find other people that are doing it. Find people that are writing the types of applications or levels that you want. You can go online to do these type of things. But just get involved, and I think a lot of good things will happen from there, just because you're surrounding yourself with people with similar interests who have different ideas you can bounce things back and forth on. And that's my presentation.